Hello everyone and welcome to today's session on high availability AWS architecture for a Netflix style recommendation service. I am Blessing Olaleye, your host, and this presentation is brought to you by DevSecOps CloudTech. Today we are going to be walking through how to transform an on-premise application into a resilient, fault-tolerant, and scalable AWS solution. This content is for educational purpose only and is not affiliated with, endorsed by, or sponsored by Netflix Incorporation. All trademarks are the property of their respective owners. Here is the scenario we're going to be looking at today. Netflix runs its recommendation service on premise, but recently the database servers crashed after a sudden power outage. They lost critical data. Our goal is to migrate this service to AWS and remove single point of failure, enable automatic failover, and make sure it can scale to meet global demand. When building this, we focus on 5 main goals. Number 1, high availability with Multi-AZ for both the app and database tier. 2, fault tolerance with automatic failover. 3, elastic scalability to handle traffic spike. 4, data durability so nothing is lost during failure. And 5th, managed services to reduce operational overhead. The correct AWS solution is to deploy the application servers on Amazon EC2 instance in an auto-scaling group spread across multiple availability zones. For the database tier, we use Amazon RDS in Multi-AZ configuration. This gives us scaling for the application tier and automatic failover for the database tier. Here's what it looks like. User connect through Amazon CloudFront. Traffic flow into the application load balancer. The application load balancer send request to LD EC2 instance in multiple AZ. Those EC2 instances talk to the Multi-AZ RDS database, and CloudWatch monitor the entire stack, triggering scaling or failover when needed. Step 1, user request enters through CloudFront. Step 2, application load balancer send it to a LD EC2 instance. And step 3, EC2 queries the RDS database. Step 4, CloudWatch check health and performance and act if something goes wrong. This design survived an AZ outage, an availability zone outage. It survived a database crash with automatic failover. It scales automatically during traffic spike, and AWS handle backups and patching. So we spend more time building and less time firefighting. We can build this entire architecture using Terraform infrastructure as code. Terraform will create the VPC, the subnet, the routes, deploy application load balancers and auto-scaling groups, provision the Multi-AZ RDS for the database, apply security group for controlled access. Our Terraform setup is organized into files. The first file is provider.tf and that's the AWS provider configuration. Variable.ts parameter for flexibility. Main.tf, that's for networking security and EC2 setup. RDS.tf, that's for multi-AZ RDS database configuration. Then we also have our output.tf, that's for application load balancer, DNS, and RDS endpoints. You can download the complete code for this configuration. That's the Terraform configuration on our GitHub page. That's github.com/DevSecOps CloudTech, AWS, Azure, Netflix, and Terraform. You can see the link right there. Just go through that link. You can download all of the documents from there. To deploy, once you pull those Terraform script to deploy, just run Terraform init to set up, Terraform apply -var equals to, you can put your password and all of that configuration information required. Then you launch. When done, you destroy the entire setup by running the command terraform destroy to remove everything. So in conclusion, this AWS design gives Netflix or similar projects a resilient, scalable, cost-effective way to run with minimal downtime and no data loss. For references and documentation, you can reference those links for documentation provided by Amazon, by AWS, and Terraform. You can reference the AWS well-architected framework reliability pillar through that link. Amazon EC2 auto-scaling documents through the provided link. Amazon RDS Multi-AZ documentation through the provided link for the database tier and the computing machine, which is the EC2 we are using in this contest. And also for the sake of reliability and availability, you can reference the other documents. And for the IFC infrastructure as code, we will employ Terraform in this contest instead of. So for that particular, you can reference the documentation provided by HashiCorp. At this point, I want to thank everyone for watching. If this video is helpful, give it a thumbs up, subscribe to DevSecOps CloudTech, and hit the notification bell so you never miss any of our videos on DevOps, on AWS, on Azure, on Google Cloud, employing several concepts and technologies such as Terraform and many other cloud initiatives and concepts alongside technology that are available. Drop your thoughts in the comment section. I would love to hear from you on this video. As I want to say thank you for everyone for watching and stopping by. Have a good one.